this is for specialist maths, exercise 2D, question 7 and question 9. So we've got a situation where we've got two numbers. So we've got two numbers, and we want to prove that one number is larger than the other. Logically, if you subtract a small number from the larger number, then the result will be greater than 0. So that's sort of what we're using the logic as. So we don't know which number is bigger, so we'll randomly choose this number to subtract, this number to subtract from this number. So I'll go 5 minus 3 root 2 minus 6 root 2 minus 8. So I'm subtracting this from that. 5 minus minus 8 is plus 8, and minus root 3 on 2 minus 6 root 2. 5 plus 8 is 13, minus 3 root 2 minus 6 root 2 is minus 9 root 2. Okay, we can't directly compare these to show whether one's bigger than the other. So what we can do, or whether that's greater than 1 or not. So what we do is convert it back into surd form. So we know that root 169 is the same as 13. 9 root 2 is the same as root 2 times 81. So root 169 minus root 162. This number is obviously bigger than this number, so that means this is greater than 0. So therefore this number is, or it is indeed larger than this number. Okay. For the second one, we do something very similar. So we want to see whether this number is larger than this number. So I subtract this number from that number. So let's do that. 2 root 6 minus 3 minus, so I'm subtracting the other number from it. Now 2 root 6 minus 3 minus 7 plus 2 root 2. I'm just expanding brackets. Minus 7 minus 3 minus 7 is minus 10. Plus 4 root 2. 4 root 6, sorry. 4 root 6. Now again, we need to compare these. I'll move this to look like that because I want to compare them. Now let's convert this to like a full surd. So that's like 4 is like root 16 times 6. So you can do 16 times 6 quickly. 6 6 is 36. 6 1s are 6. So 96. So this is root 96 minus root 10 is the same as 100. Root 100. So this is smaller than this, which means the whole thing has to be less than 0. So therefore, when I subtract this number from that number, I get a number less than 0. So it means logically that this number is larger than this number. So the result is 7 minus 2 larger. And in this in the first case, 5 minus 3 root 2 is larger. So question 9, it says find values for the quadratic function x squared plus bx plus c such that the equation of the solutions are. So you know, when it says f of x equals 0, it's basically saying f of x is like y when y equals 0, so it's basically the root solutions or the x-intercepts of this function. We want the x-intercepts of this function to be something like root 3 and negative 3. So remember in factor form, if I have x minus a, x minus b greater than 0, by null factor law, we know that x minus a is equals 0 or x minus b equals 0. So x therefore equals a and x equals b. We can use something very similar here. So for 9a, we know the solutions are root 3 and negative root 3 because it says so. Now, putting it in this form, we know the solutions would be x minus root 3 equals 0, x plus root 3 equals 0, so x equals root 3, x equals negative root 3, which is what we want. Yep, so which is what we want. Now, the answer states that we need to find the values of b and c in this form. Now, there's no dilation factor because there's no number in front of the x squared, so we don't need to worry about like having a k at the front, say. So all we need to do is just expand this. Now, x minus root 3, x plus root 3 is a difference of two squares, dots. So it's just equal to this squared minus this squared. So minus root 3 squared is minus 3. So therefore, your a value, your b value would be 0, because we have no coefficient of x, and your c value is negative 3. So for something like part B, we've got something very similar. So we know that x minus 2 root 3, x plus 2 root 3 will give you the solutions. So we set y equals 0, we will get the same solution. So expanding that, again, it's a difference of two squares because we had a plus this and a minus of this and a plus of this. So it's x squared minus 4 minus, so square of that is 4 times 3. That's good, 4 times 3. Because I'm squaring the 2, I'm squaring the 3, which gives you that result. So y equals x squared minus 12. So therefore your b is 0 again, and your c is negative 12. Now let's go to a more difficult question. So part C. We want the solutions x plus 1. So we want the solutions 1 minus root 2 and 1 plus root 2. So the only way you can get that is if you go x minus 1 minus root 2, x minus 1 plus root 2. So by a difference of two squares, we can group these terms into this, and plus minus root 2 and plus root 2. So your difference of two squares would look like this. X minus 1 all squared minus root 2 squared. So that equals, expanding that, we get negative 2x plus 1 minus root 2 squared is just 2. So therefore x squared minus 2x minus 1. So therefore your b term is negative 2 and your c term is negative 1. So do it like that.